Here's the solution for day 2, problem 1. Question A, identify the slope and y-intercept for the graph of y equals 2/5 x minus 2. And then part B, graph this equation. So for question A, the first thing we're asked to do is identify the slope, which is also called the rate of change of the equation. Because of the form of this equation, where the letter y is alone, and then after the equal symbol is the x term, and then the constant term, there's a very fast way to get the slope. In this form, the slope is the coefficient of the x term. It's 2/5. Now we're asked for the y-intercept. In this form, the y-intercept is the constant term. In this case, -2. Okay, in part B, we can use these two values to graph a line for this equation. We'll start with the y-intercept because the y-intercept is a dot on the line. The slope is not a dot. The slope is a pattern of traveling from one dot to another dot. So let's begin with the y-intercept. It is at -2. So on the y-axis, here's -2, and put a dot there. Now we can use the slope, or rate of change, to get another dot on the line. Thinking of this as a rate, y is on top, x is on bottom. The y increases by 2 when the x increases by 5. Let's do that with our pen. So we're going to start at this dot. Increase the y by 2, 1, 2. And increase the x by 5, 1, 2, 3, 4, 5. Here is another dot on the line. And we can draw the line through, and we have it. Now day 2, problem 2. A child is learning words. The table shows the number of words learned since the child first starts speaking. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and the initial value. And as I look at the data, in the first column, we have the variable t, the number of months after the child starts to speak, 3, 6, 9, 12. In the second column, we have the variable n, and this is representing the number of words learned, 120, 240, and so on. First thing we're asked to do is find the rate of change. And we can do that by looking at the rows of the table. We can look at any rows we want, but we could look at the first to second rows. So from 3 to 6, that has changed by 3 months. And in that 3 months, the number of words learned has changed from 120 to 240. It has increased by 120 words. Writing this as a rate, 120 words in 3 months. And then we can simplify this. 120 divided by 3 is 40 words per month. That is the rate of change. Okay, now we're asked to get the initial value. The initial value is the value of n, that is the number of words learned, when the value of t is 0. This doesn't begin with 0, so we're going to have to count backwards to 2, to 1, to 0 to figure out what the value of n is. Okay, so initial value. We are keeping track of months in the table, and we're keeping track of number of words in the table. Let's do some working backwards. The first row of the table, 3 months, has 120 words. Let's work backwards from there. So after 2 months, how many words did the child know? Well, this child is learning 40 new words every month. And so 120 subtract 40 is 80 words. 2 months after the child first learned to speak, she knew 80 words. Let's work backwards again. 1 month. 80 subtract 40 is 40 words. And one more time, because initial value is when you have 0 for your independent variable. So for the 0th month, 40 subtract 40 is 0 words. That makes sense, right? This is talking about the child first learning to speak, And so at the initial value, when the child first learns to speak, she knows 0 words.